300 longest increasing subsequence. So this is a very famous problem. So we're gonna directly call it LIS. So it's gonna be a longest increasing subsequence problem. So there's gonna be a lot of similar problems. So maybe there's gonna be more than 15 similar problems in Leetcode, but this is gonna be the basic pattern. Normally we're gonna use two methods. So the first method is gonna be dp. The time complexity is going to be n squared. So the idea is that, for example, we have some numbers like 1, 2, 4, 3. So if we are going to calculate the longest increasing subsequence, so it is strictly increasing. So for example, if we are going to check this number 3, yeah, so what's going to be the longest increasing subsequence if we are adding with this number 3 at this position? So for example, this position is I. So 3 is going to combine with 4, but it is not in increasing order, but 3 with 2, it is increasing. So this is going to be a possible result, and 3 and 1 going to be a possible result. But for 3 and 1, the longest increasing subsequence is 2. But for 3 and 2, because 1 and 2 is a increasing subsequence, so 3 and 2 it's going to become 3. So the longest increasing subsequence is going to become 3 because 3 with 2. But for this 2, we're going to have a value of 2. So yeah, so fi is defined as the longest increasing subsequence adding with index I. So this is going to be the definition. So this means we're going to use the two for loops. Yeah. While we are iterating with the outer loop I, we're going to use another inner loop to check all the numbers before it. So if it combines, if this number, for example, is less than 2, this number 2 is less than our current number 3. So we're going to use the formula. So fi going to equal to fj plus 1. Yeah, fi going to equal to fj plus 1. But we're going to choose the maximum value of all the possible results. Yeah, so this is the basic idea. We're going to choose the maximum possible result of fj plus 1. So the condition is that nums j gonna less than nums I. So this is the dp idea. So the time complexity gonna be n squared. Yeah. So another method is we're gonna call it greedy method. Yeah. So it is the greedy idea. Yeah. So for example, we're gonna still have the same number. So 1, 2, 4, 3. So the idea is from the beginning we're gonna prepare an empty array. It's gonna be f. So f gonna equal to an empty array. So let me make it better. So this is f gonna equal to an empty array. Now we're gonna put all the numbers inside of f. For the first number, as there's nothing inside, we're gonna put the first number inside. And then for the second number, because this 2 is more than 1, definitely we're gonna append 2 after 1 because it's gonna become longer. 1 to 2, it is in increasing order. Next, we're gonna put 4 inside. It is still in increasing order, so the length is 3. Yeah. But for the next, if there's a 5, we're gonna put the 5 at the end. But now it is not 5, it is 3. Where we can put the 3. So this is 1, 2, and 4. So we're gonna put the 3 at this position. Because according to the greedy idea, if the next number is 4, we're gonna have the longest increasing subsequence. It's gonna become 4. Yeah. Otherwise, if we put 4 here, for the next number, if it is 4, it is not the longest increasing subsequence. It is 3, not 4. This is why, according to the greedy idea, yeah. Currently, we are having this number 3. Where are we gonna put this 3? Definitely, we will not put it here because 3 is more than 1, 3 is more than 2. And why we can put it here? According to the binary search, we can put it here. It is the log n time, so the time complexity is going to be n log n. So this is going to be a better idea. So we're going to put 3 here. Yeah, so this means 4 going to be covered by 3. So here at this position, we're going to put a 3. And the next, maybe we're going to have a number 4, and maybe we have a number 5. So the longest increasing subsequence is going to be length of the array f. Yeah. So this is the n log n time. Yeah. Now let's just try to first use dp to solve the problem. So we're gonna define n as the length of the nums array, and we're going to define the dp table. It's going to be 1 times n. Because for the dp table, for any number, if there's only one number, definitely the longest increasing subsequence is 1. So this is why we're going to put a 1 inside of the dp table, inside of the f array. Now we just need to use two for loops. The outer loop is I to n, and for j to I. So the condition is that if nums j is less than nums I, so we're gonna update the f. So fi gonna equal to maximum of fi with fj plus 1. Yeah, because we're gonna consider this number nums I, and we're gonna consider all the number before it. So it's gonna be fj. So fj plus 1 gonna be the longest increasing subsequence. But we're gonna compare the maximum. We're gonna compare all of them. So this one at this place is gonna be the longest increasing subsequence. But for the final return, we're gonna return the maximum of f. Yeah, because it can be at any place. We are not sure. So this is why we're gonna use max. Yeah. Now let me just submit it to tag if it works. Yeah. Now as you can see, it works, and the speed is okay. It is 2 seconds, and it is okay. Yeah. Now let's just use another idea. So another idea is greedy idea. So we're gonna use the greedy idea. So we're gonna first of all we're gonna define an empty f array. Now we're gonna check all the numbers inside of the nums, as I explained before. So we're gonna use a boundary search. So here we're gonna use bisect left because it is strictly increasing. So we're gonna bisect left to check this number, and we're gonna check it inside the f array. Now we need to check if this I equal to the length of the f array. It means we need to put it at the end. So f gonna append this number. Otherwise, this means we're gonna insert it at the place in I. So fi gonna update it to this number. It's gonna be covered by this number. So finally, we're gonna return the length of the f array. Yeah. Now let me just run it. What is wrong? Object of type integer has no length. I don't know. Yeah, I write it wrong. First of all, it's gonna be this array, and then it's gonna be this number. Yeah. So this is the bisect. How to use the bisect left? First, it's gonna be the array, and then we're gonna use the number to check. Now let me just submit it to check if it works. As you can see, it works, and it's pretty fast. Before it is 2 seconds, now it becomes 5 milliseconds, because the time complexity currently becomes nlogn time. Yeah, and we have to learn on this kind of method because there's a lot of Leetcode problems for the longest increasing subsequence pattern. We have to solve it in nlogn time. Yeah, so this is why instead of learning n squared time complexity, we have to learn another way, nlogn time. It is yeah, the coding it is from here. So the basic idea is the greedy idea. Yeah, I think that's all about it. Thanks for watching. See you next time.